Hello everybody, welcome back. So in the previous session I had discussed on how to set up and debug Hifive1 revision B board with the GDB and OpenOCD. Though this session is going to be a detached session, still I would be using the OpenOCD and GDB to connect and debug on the board. So if you haven't watched the previous session, I highly recommend you to watch that before getting into this. So let's jump in. So what I'm gonna discuss in this session is are two things. One is the boot up sequence of the Hifive1 revision B board, and the other one which you need to know before developing or writing any firmware is the clock settings. Okay, but so the key takeaway at the end of this session would be this one, that I just figured out something, that though the Hifive1-Rev manual says that these are all the 4 boot options, I realized, or I found and came to know that this is the first 3 options cannot be set on the board. So if you want to know that, stay tuned. So let's jump in. So first, so the clock setting on the Hifive1 revision B board. So if you go through the FE310G002 SOC manual, then there are 2 chapters dedicated for these two. One is for the, what is that? So the boot process is on chapter 5 and the clock generation is on chapter 6, but I'm not gonna go through each and every line of that, but I just captured the clock setting in this one single slide. So this clock setting is, or the clock for the board or for the SOC is generated in 2 blocks. One is the always on block, which has a low frequency clock generation. Other one is the PRCA block, which Hifi has the acronym is a power reset clock interrupt. Okay, so this generates a high frequency. So on each block you have an on-chip ring oscillator for both low frequency and high frequency. Though you see here, though this is a ring oscillator, and you have a divider on chip or the trim options, and then there's an option to connect with the external crystal on both the cases. And the high frequency can also be connected directly to your external crystal. And in the case of PRCA block, you have a PLL, and so you have options to, I think the ring oscillator is capable of I think it's 72 megahertz. So you can tune through this trim options and then the PLL settings, so you can get a variety of or the range of high frequency clock ranging from maybe close to 0 to 72 megahertz on this. And I'm not sure, so I'm not gonna go into the always on block now. The reason is the default setting or the default clock option right after the reset on this Hifive1 revision B board is the ring oscillator on the PRCA block. So this, as I said, the internal trimmable or programmable ring oscillator is 72 megahertz, and you can connect through the PLL, and with the PLL settings you can you can vary the high frequency clock output, and this is controlled by the high frequency oscillator configuration register. And this is what, and the values whatever that's mentioned here is the default values right after the POR or power on reset. Okay, so this is the if you see here, whenever the clock, once you set and once the clock is ready, that's when this flag will be set. So it's just read only for the user, it cannot write anything, and this is to enable the clock, and this is reserved. And these are the 4, so I think 4 or 5 bits of the trim options. Yeah, 5 bit tap options for the ring oscillator, so which would vary you can vary this between slow frequency to the maximum of 72 megahertz. Then this is the high frequency oscillator division. You can divide the outputs out, which gets you from 1.125 megahertz to 72 megahertz. Okay, so that's in a nutshell, that's the main thing you need to know to start with the revision 1B board. And let's read from the board. So this is where I mentioned that I wouldn't be, if you want to know what these are, then you should, if you don't understand this, then you better go back to the previous session and then come back to this. So that's the connector to the OpenOCD. I'm just loading and just loading the code into the RAM. And for this session, it doesn't matter what code I'm loading into the RAM, because the code of which I used in the previous session is nothing but an addition of two numbers, and then there is an infinite loop. So if you wonder what this would do, is just it would display the instruction at the memory pointed by the program counter. Okay, so this is how you step in, but what I really want to do is this one. That's the to read the high frequency oscillator configuration register. For that, to get the address of that, what we need to do is you go to the clock generation, and this is the high frequency oscillator configuration register, which says this is in the PRCA block of offset 00. Okay, so if you want to go to the find the PRCA block address, you go to the memory map. So this is where you see the PRCA block. So it starts with, yeah. So that's the address of the PRCA block. Let's go to the clock generation again, and so the offset is 00. So that means the HF or OASC config register address would be same as this, because with this and the offset of 0. So in GDB you have the examine, and the option you want to see as 1x, and let's paste the address. So if you see the 32-bit values at this address, which is the high frequency oscillator configuration register, is this. Now let's dissect that. So that's what. So you see here it's C01 followed by 4 zeros and 4. Okay, so if you expand that 32 bits, you can see that the clock is ready, and the crystal oscillator is ready, and the enable bit is set to 1. these are the reserved, so 9 bits, and then the trim option is 5, and again reserved, and the last value is 4. So this would give a default clock frequency of 13.8 megahertz. So I would love to probe this, but I don't have an oscillator right now. So soon I would probe and see if the frequency is right. But for now, so this is the clock settings by default when you get the Revision 1B board. Now jumping into the boot options, if you see the boot option on chapter 5, so this is where I got misled. So when I went through this boot options, I read those 3-4 options, and so the default option on the board right now is 1-1. That's what it says. But what would I like to do is to set to 0-1. So when I try to set, so this manual says that you can control this boot options with the select pin. So that's when I ordered the Hifive1-RevB chips. But then when I searched through the schematics, I couldn't find these pins anywhere. So for example, if you search here, you don't find the select pins. So that's when I was wondering, how would I be able to change the boot settings on this? So that when I posted a question in the sci-fi forum, the result was surprising. So it seems that the select pins are fixed at 0-3. That means it's hard coded to this 1-1, and the bad thing is that it's not modifiable. So this cannot be set to any other boot option right now on this Hifive1-RevB board. That's what I came to know from this forum reply. I can post this link in the description or comment section below. So so knowing that this cannot be changed, but I think it's not gonna make much difference for my own board, because what the difference between these two are that I will come to that very soon. Let's go and see with this boot option 1-1 how the boot process is. So let's go to the manual again. So this is the reset vector. Okay, so the boot process is very simple. So on power on reset, the reset vector is mapped to 1004 address. Okay, so the moment the board is resetted, it would jump into this. Okay, here what it does is it loads the add upper immediate of the program counter, and it will load it into T0. So program counter plus 0 would be loaded into the destination register, which is T0, which is effectively T0 would have this address or this value in it. Then the next line would be like load word from the address pointed by T1. Load the value from the memory pointed by T0 -4, because the offset is -4, and then load the word into this T1. So that means that the T0 is going to have this value. So -4 would take you to this address, and which is like select pin state. So it should be, ideally it should be, theoretically it should be able to have one of these 4 values, but in this board it seems that it's not modifiable. So whenever you read, it's gonna get you 1-1. So then it's a logical OR with 0 3, and it jumps. If you dissect this, it would jump into the master ROM. So that's what the thread post, the post in the forum. So this is the same thing, but what I learned more from this reply in the forum is so what is there in the OTP memory and how it jumps into the flash as explained and dissected very well, because I couldn't find the content into the OTP, because all I can see is that execution jumps from our whatever the code is there in the flash, it is able to work from here. But this part was missing. But this forum reply, whoever it is, Javid, I really thank him for this, and you should really go through this a link. I will, whatever I have posted in the description, please go through that to understand it. So what this basically does is, so right after the board reset, so it would jump into the reset vector, which is this address. Then it executes this. Then from there it jumps into the mask ROM, which is again fixed during the manufacturing. We can't change. So I don't know if I would have been able to get this information in some of the documents or not, but I got this information only from this post in the forum. So that's why I said, so this is a very useful information for me. And from the contents of the master ROM is this, and then from there it executes into the address to which is 2 followed by 4 zeros, which is again a one-time programmable memory. So these contents we cannot change. Okay, so anyway, so and finally from that it does the low-level init and then it jumps into the QSP allocation, which is this, which is nothing but the flash address. If you see here, 2 followed by QSPI. So from, let me keep it side to side. So you see, so this address belongs to the flash off chip NVM flash, and if you see the linker file of the Freedom ESDK or Metal, you would see that the application code would be flashed at this address. So that's how the boot up process works. But let's see if this is what is there in the memory. So let's go to the coding again. So let's go and jump into the 1004. So x/4x004. Okay, I will set this as I. So if you see here, so this stands for examine, and number of instructions I want to, from this memory, I want to examine 4 instructions. I for instruction initial, when I type X, which stands for show the values in hex, that's when we got that. But when I change it to instruction, so you see here, it correlates well with whatever the it's mentioned in the forum, as well as whatever is there in the let's go to the in the manual, or what is that? Boot options. You see here. Okay, so that's just a takeaway for me that though this manual. So if you have plans to get any of this processor or the chip, and if you want to if you want to know, then please be informed that this is, you can't change the boot option of this chip anything other than 1.1. But there isn't much difference for me between this one and this one, except that this goes through the OTP and mask ROM, and then it comes back to this, so it's okay for me. So once I get the chips, I should be able to still pursue whatever I wished for. So that's it. Please, if you have any questions or anything, please put ask on the comments, and I will try to answer it. Thank you. See you in the next session.